Hello class. In this video, we're going to talk about parent-child relationships amongst database entities. We've seen as we've worked through some of our examples that we could easily create a database table that contains information about one entity. The entity that we used was a student. In this picture, they're looking at a teacher's entity, and in their table, they have a teacher ID, which is their primary key, their unique key. They have the name, office, phone, and email. Well, that teacher can have classes. So in the classes table, we have some other information. Let's take a look at it first. We have class ID, the course code, when it is, all that stuff. But then we also have the ID of the teacher that is teaching that class. When we have a key like that in a table that belongs to another table, we call that a foreign key. And in the database, we can create a relationship on those keys so that we know all the classes with a certain teacher ID are related to a teacher row with that same teacher ID. So we can use that to facilitate us gathering data and updating data and deleting things, because if we delete that teacher, then we can either eliminate that teacher ID from those classes, or we could delete all those classes, depending on whether we wanted that delete to cascade. If it cascades, we would delete all of the associated classes. This line here is used in this entity relationship diagram to show this relationship. And it's showing that for one teacher, we could have many classes. And that's what that kind of modified crow's foot notation is. They're showing that we could have many of these rows for one row in our teacher's table. So in our application, so far we've been working with our student, or actually our member table, which has student information. Earlier on, we created a derived class that was deriving from our student class, and we called that the graduate. Our graduate contains these two class fields, the degree type and the alma mater. Well, if we want to carry through this relationship from our class structure, our business logic, and our application to our database, as we need to, then we're going to need to create a graduate table that has a relationship with our employee or our student table. So let's open our SQL Server Management Studio and go to our server. I'm going to expand the databases to find my database, and expand my database to look at the tables that I have. I'm going to delete that one. Let me see if it will let me, because I have created some things about it. Okay, and it's gone. So in our member table, if we review, I'll say look at the design of that. We have a column called ID that is our student ID, the last name, the first name, and the phone number. So we're going to add a new table that carries the graduate type student's information. Now, there are some things about database design that say we can't just add that information to this member table, our student table, because the information does not apply to all students. So since it doesn't apply to all students, we need to separate that out into another table. And that table is going to be dependent upon our member table. So let's create a new table. I want my ID column to be named the same for consistency. It doesn't have to be, but that will help us be consistent. We'd like it to be the same data type, and I'm going to make it our primary key. Now, in our situation, we can use that student ID directly as a primary key. In the example we were looking at earlier, our classes, if you notice, have a separate primary key, and we just have a relationship off that teacher ID. Our structure is going to be a little different in that we're going to have a one-to-one relationship. We would never have more than one graduate record for a given student, so we will be able to use that same ID field for both tables. In our class, we had our degree type column and our alma mater. That's all we needed to carry for our graduate students. So let's save that. This will be our graduate table. Now we need to establish the relationship between this table and our member table. So we're going to use the table designer to set up our relationships. I want to add a new relationship, and in this area of the window here, it gives me the relationships characteristics. So I'm going to take a look at this. First of all, the tables and columns. I need to change this setting, so I'll click on those three dots. Our primary key table is going to be our member table, and in our member table, the column that we're using is our ID. Our foreign key table, the table that has a relationship with our primary key table, is going to be our graduate table, and we're also going to use the ID column for it. Now, if I look further down in this description, I have some information about insert and update specifications. It says for deleting, do you want there to be any sort of action? Right now it's defaulted to no. I'm going to say yes, I would like to cascade. If my student member table record gets deleted, that row, I want to delete the associated graduate record. Now, what if my member table gets updated? Again, I'll set it to cascade. If that ID field were to be changed, I would want it to be updated on the associated graduate records. We won't allow that in our application, right? So now, yes, we are enforcing these foreign key constraints. That means that we're not going to allow anybody to create a graduate row in a table unless a row in our student member table already exists for that ID. I'm going to close that now, and I'm going to save everything again. Now it says that besides saving your graduate table, this is going to cause a save to your member table. We've updated that member table definition by adding this relationship. So yes, I want that to happen. Good. Now I can close these design mode windows, and I want to create a new query. We've seen from our practicing so far that the insert command will allow us to insert rows into a table. First, let's select everything from our graduate table. What's a minute? Let me refresh here and make sure it got properly saved. It appears that it did not, huh? Oh no. Well, let's try that again. Get a little more practice here. I saved you. Save. Okay, I thought you did. Wait a minute, does that? Finally, I just had a little bit of a delayed reaction there. So no, I don't need to save anything. Now, let me try that query again. Whoops. Nothing, so we have no rows. Now we know that an insert command will add to our table. So if we say we want to insert into graduate, we remember from our C# syntax, we can specify a list of columns, ID, degree type, and alma mater. And then we can have our values. And I'm going to make all of those strings being enclosed within our single quotes. We'll say our degree type is BS, and our alma mater is MSU. All right, let's try and execute this insert statement. I'm going to select it so that when I click execute, it's the only command that runs. It says, it conflicted. It says it conflicted with the foreign key constraint. The conflict occurred because the ID was not found in our member table. Makes sense. Let's select everything from our member table and review what we have. I just want to run this line of code. Now here are our member table contents. So I'll just pick one that I want to add this to. So let's add it to Joe Schmo here. He's the guy that we added ourselves. So his ID is 6758. And I just want to execute this. So I will run it. There we go. Now it says one row was affected, so we should have had a row inserted. Let's run our select and see. Sure enough, now we have this associated record. Well, that's great, but notice that just with that number, it doesn't mean very much. So we can use an SQL join command to tell the database that we would like to join the information from these two tables based on this similar ID. So we can modify our select statement, and I can say that I want to select everything from, let me see which one I want to use first. I'm thinking it's hard for me. Probably our member table, right? He's our controller. So with our member table then, we want to do a join with our graduate table on our member table ID being equal to our graduate ID. Now that creates that join specification right there that says that we want all of the rows from our member table, and we would like to have all of our rows from our member table, and if there's an associated graduate table, we'd like to see that too. Is this going to do that for us? No. Notice it only gave us the row where we actually had a graduate table existing, not all of our rows. So this join worked. It's just that it didn't give us everything that we want. So we want to do what's called an outer join. Okay, so SQL Server left join, much happier. A left join meaning take all of the data from this left hand table or member table and join the right hand table to it if you find an instance of a matching item. So we'll run that now, and that looks better. We see all of the rows from our member table, and we are only seeing the graduate information from our graduate. So you can use this information for your employee project. You'll need to be setting it up using the two tables instead of just one, as we did in our examples for the video, so it will be a little bit challenging for you. If I want to insert a new row that affects both tables, I would of course insert my my student row member table item first, and then I would insert the graduate row afterwards, because remember that member table has to exist first because of our relationship that we've established. Okay, that should get you going on creating a table to finish up your employee project. Thank you.